Hello everyone, myself Dr. CH.Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the today's session on surface integrals. An overview of today's presentation. Today I would like to introduce the surface integral and then how to evaluate the surface integral. Surface integral is the generalization of the concept of a double integral. So, double integral f of xy dx dy, for example. There must be two variables, for example, x and y. So, we need to integrate with respect to x as well as with respect to y. In general, in a double integral, the double integral f of xy, first with respect to x, then with respect to y, dx dy is same as the double integral if we integrate first with respect to y, then with respect to x. Both gives the same answer. And surface integral is the extension to this or the generalization of this concept to the vector field. And a surface integral, in surface integrals, for example, if we consider x and y are the variables, then we need to integrate with respect to x as well as y. In this case, either we find the limits of y in terms of functions of x. For example, f1x to f2x. Y changes from f1x to f2x and x changes from a to b, constants. If one of the limits is constant, then we get a numerical answer. We can consider like this, or else x limits as functions of y, g1, y2, g2, y, and y limits as constants, c to d. So, we can consider the limits either in this form or in this form. Similarly, in yz plane and xz plane also. And in general, the double integral can be obtained by taking the projections of the surface S in three different planes. For example, if R1 is the projection of S in xy plane, if I take the projection in xy plane, then the surface integral can be calculated in the xy plane by integrating with respect to x and y and taking the limits from x and y limits. Similarly, if I take the projection in yz plane, then we need to find the surface integral in yz plane by integrating with respect to y and z and the limits of y and z. Similarly, if I consider the projection on xz plane, then in xz plane we need to integrate with respect to x and with respect to z and take the limits of x and z. Now the surface integral. Let us consider a vector f bar and r bar is a projection. R bar is the projection. Now let us consider a vector f bar and we need to evaluate the surface integral of this vector over a surface, a capital S. And to evaluate this surface integral, we consider the projections in xy plane or yz plane or xz plane. And a surface integral can be defined as integral S over S f bar dot n bar ds, where n bar is the unit normal vector to the surface. And here, just now as we discussed, if I consider the projection R1, projection of the surface S on xy plane, then this surface integral f bar dot n bar ds will be the double integral f bar dot n bar we are considering the projection on xy plane, so we integrate with respect to x and y divided by n bar dot mod n bar dot k bar. Since for xy plane the perpendicular axis is z axis and the unit vector along z axis is k bar. So outward drawn unit vector. Similarly, R2 yz plane, if I consider the projection of the surface, on yz plane, then this surface integral f bar dot n bar ds will be the double integral f bar dot n bar dy dz, because we are taking yz plane, and for yz plane the perpendicular one is x axis and along x axis I bar is a unit vector. So n bar dot I bar. And also if I consider xz plane, the projection of the surface in xz plane, then the surface integral f bar dot n bar ds will be f bar dot n bar by mod n bar dot, for xz plane the perpendicular one outward drawn one is y axis, and along y axis the unit vector is j bar, and since it is xz plane we integrate with respect to x and z. So to evaluate this surface integral, we can consider either the projection on xy plane or yz plane or xz plane. That means we can consider any one of these three formulae. Let us discuss the method of evaluation of surface integral. The problem number 1. Evaluate surface integral f bar dot n bar ds, where f bar is and s is the part of the surface of the plane located in the first octant. So in the given problem, the vector f bar is 18z I bar minus 12j bar plus 3yk bar. This is the given vector f bar. And what is the surface? Is a part of 2x plus 3y plus 6z minus 12, or is equal to 12. This is the plane given. So what is the surface integral? First, the formula for surface integral. Surface integral. Let us consider, just now I told, we can consider any one of those three formulae. That means we can consider the projection of the surface either on xy plane or yz plane or xz plane. Let us consider the projection of the surface S on xy plane. If I consider the projection on xy plane, then the surface integral f bar dot n bar ds will be the double integral f bar dot n bar dx dy by mod n bar dot k bar. This is the formula to evaluate the surface integral. So first we need to calculate all the required values. So here we have n bar. What is this n bar? Unit normal vector to the given surface. So what is the given surface? Given surface. Let us denote the given surface by phi. 2x plus 3y plus 6z minus 12. Now we need to find n bar. So what is n bar? N bar is the unit normal vector. First we need to calculate the normal vector. So what is the formula to find normal vector? We know that the normal vector to the surface phi is given by del phi. The normal vector to the given surface phi is given by del phi. So del phi means the grad phi, gradient of phi, which is dou phi by dou x I bar plus dou phi by dou y j bar plus dou phi by dou z k bar. And here we are considering on xy plane. So therefore, okay, let us calculate this: dou phi by dou x I bar, dou phi by dou y j bar, dou phi by dou z k bar. So first we need to calculate the partial derivatives of phi. Dou phi by dou x So with respect to x partial derivative, here this is the term having x. So dou phi by dou x is 2 I bar, dou phi by dou y 3j bar, dou phi by dou z 6k bar. So this is the normal vector to the given surface. But what is n bar? Unit normal vector. So therefore n bar is del phi by mod del phi 2i bar plus 3j bar plus 6k bar by what is mod del phi? Under root sum of the squares of the components 4 plus 9 plus 36. So 36 plus 4 40 49. So n bar equal to 1 by 7 into 2i bar plus 3j bar plus 6k bar. This is the unit normal vector n bar. Next we need to calculate f bar dot n bar. Now f bar dot n bar is given by, what is the given vector f bar? 18z I bar. 18z is the first component. So let us write that f bar here, 18z I bar minus 12j bar plus 3y k bar. And what is n bar? Just now we have calculated 1 by 7 2i bar plus 3j bar plus 6k bar. 3j bar plus 6k bar. Now we need to find f bar dot n bar. And we know that the dot product between two vectors is the sum of the products of corresponding components. So 18z here and this 1 by 7 into 18z into 2, 36z minus 12 into 3, 36 plus 18y. The dot product gives a scalar. So here we got a scalar. There will not be any ijk. Since I dot is 1, j dot j is 1, k dot k is 1. And here we can take 6 common, 6 by 7 into 3y plus 6z minus 6. So this is f bar dot n bar. And also we need to calculate n bar dot k bar. So n bar dot k bar, this is n bar dot k bar, only the last component. So 6 by 7 is the answer. So to evaluate the surface integral, again the formula in xy plane, if you take the projection, f bar dot n bar ds is f bar dot n bar by mod n bar dot k bar dx dy. So that means we need to find the limits of x and y. To find the limits, let us use the given. So limits. Given 2x plus 3y plus 6z equal to 12. 2x plus 3y plus 6z equal to 12. But in the xy plane, z is 0. So therefore, 2x plus 3y equal to 12. That implies, now to find the limits, there are two ways. Either we can find y limits in terms of x and x as constants, or x limits in terms of y and y as constants. So let us find this y limits, 12 minus 2x. So y equal to 12 minus 2x by 3. Since it is clearly mentioned that the surface of the region or the given surface in first octant, therefore y changes from, or y varies from y equal to 0 to y equal to 12 minus 2x by 3. So this is equation 1. So put z equal to 0 in 1, then we get 2. Now to find x limits, put y equal to 0 in the equation 2. Here put y equal to 0. Then we get 2x equal to 12. So x equal to 6. That implies x changes from x equal to 0 to x equal to 6. So like that we find the limits. Here these are the limits of y and these are the limits of x. Now let us start integrating the given. So therefore the surface integral Therefore, the surface integral f bar dot n bar ds is equal to the double integral f bar dot n bar by mod n bar dot k bar dx dy, where the x limits are constants. So, we integrate with respect to x loss at the last. So, 0 to 6 and y limits from 0 to 12 minus 2x by 3. So, upper limit 12 minus 2x by 3. And what is f bar dot n bar? F bar dot n bar is 6 by 7 into 3y plus 6z minus 6, first with respect to y, then with respect to x. Now, once again here we can observe that this is a double integral with respect to x and y, but here we have z also. So, we need to replace this z, write z in terms of x and y. If there are 3 variables, we cannot integrate this. So, from the given surface or plane, 2x plus 3y plus 6z equal to 12. 2x plus 3y plus 6z equal to 12. So, 6z equal to 12 minus 2x minus 3y. So, here we have to replace this z by a function of x and y. So, we have to transform z into x and y, because this plane is in the first octant, but we are considering the projection in the xy plane, and hence we put z equal to 0 to find the limits, but not to find this integrand function. So, here we cannot substitute z equal to 0. We have to replace this z using the given relation. So, therefore, that is equal to integral x from 0 to 6, y from 0 to 12 minus 2x by 3, 6 by 7 is constant. And here, we are missing this n bar dot k bar also. What is n bar dot k bar? 6 by 7. So, simply these two gets cancelled. So, here there is no constant term here. So, 3y plus 6z is 12 minus 2x minus 3y minus 6 dy dx. So, which is equal to, let us simplify this, 3y minus 3y cancel. So, 6 minus 2x, first with respect to y, then with respect to x. So, x from 0 to 6, y from 0 to 12 minus 2x by 3. So, this is equal to, first we need to integrate with respect to y. So, here 6 is a constant. So, 6 into integral dy, which is 6y from 0 to 12 minus 2x by 3 minus, for whole 6 minus 2x is a constant. Now, we need to integrate with respect to y first. So, this is equal to x from 0 to 6, and here 6 minus 2x is constant. In double integration or triple integration, while integrating with respect to one variable, we treat other independent variables as constants. So, in multiple integrals, if we are integrating with respect to x, we can treat y and z as constants. So, here we are integrating with respect to y, and here the function is having x. So, it's a constant into integral dy, which is y from 0 to 12 minus 2x by 3 dx. So, x from 0 to 6, this is 6 minus 2x into the upper limit 12 minus 2x by 3 dx. Just only the simplification part is left to evaluate the integral, simplify and apply the limits. That's it. So, here 1 by 3 is constant, x from 0 to 6. Here I can take 2 common. So, 3 minus x. Here again 2 common, 6 minus x dx. So, which is equal to 2 into 2, 4 by 3, integral from x equal to 0 to 6, 3 minus x into 6 minus x dx. So, therefore, f bar dot n bar ds, the surface integral f bar dot n bar ds is equal to 4 by 3 into integral x from 0 to 6, 3 minus x into 6 minus x. 3 minus x into 6 minus x dx. So which is 0 to 6 x square minus 3x minus 6x minus 9x plus 18. So again using the formula x power n plus 1 by n plus 1. This is equal to x cube by 3 minus 9x square by 2 plus 18x. The integral of x square is x cube by 3. Integral of x is x square by 2. And 18 is a constant. So integral dx is x from 0 to 6. So 4 by 3 into 6 cube. I can write it as 6 into 36 by 3 minus 9 into 36 by 2 plus 18 into 6. I can write it as 3 into 36. So we can take this 36 out, and this is 2 times. So 4 by 3 into, this is 72 minus 9. So 36 out. So 2 minus 9 plus 3. So this is 12 times. 4 into 12, 48. So here by 2 is there. So 5 minus 9 by 2, which is 48 into 10 minus 9, 1 by 2. So the answer is 24. Like this, we evaluate the surface integral for the given vector function. Similarly, let us solve one more problem. Again, the f bar is given. Evaluate integral f bar dot n bar ds, where S is the surface of the cube bounded by. So here the given surface is a cube. So given f bar 4xz I bar minus y square j bar plus yz k bar, and the surface is a cube and the lines are given. So x equal to 0, x equal to, the cube is bounded by these lines. So depending on the given data, given information, we evaluate the surface integral. So the procedure may vary with the given data. In the last problem, we have considered the projection of the surface, whereas here I can draw this cube. And this is x-axis, y-axis and z-axis. And let us denote the points. This is origin A, B, C, P, Q, R, S. Now, evaluation of surface integral, where the surface is a cube bounded by these lines. We need to evaluate over each face. So here, therefore, the surface integral f bar dot n bar ds is sum of 6 surface integrals, because a cube has 6 faces. So this is, let us consider the surface on x axis. So ABQS over ABQS, this surface, plus opposite to this surface integral, opposite face OCPR f bar dot n bar ds, plus now consider the surface on z axis PQRS PQSR over PQSR f bar dot n bar ds, and opposite to this face over OABC f bar dot n bar ds. So 4 faces are over, plus now the top one, which is on y-axis, over PQBC f bar dot n bar ds, plus bottom face ORSA f bar dot n bar ds. So in this particular problem, since the surface is the cube and cube has 6 faces. We need to evaluate the surface integral over each face. Now let us start finding the surface integral over each face. Now first one, over the face ABQS. ABQS. And here one more thing we need to identify is, since the cube is bounded by x equal to 0, x equal to a, y equal to 0, y equal to a, z equal to 0 and z equal to a, here the length from this 0 to O to A is a. Similarly, from 0 to here also, this is x equal to a, and here y equal to a, and here z equal to a. So first face is ABQS. ABQS. So on the face ABQS, the value of x is a, that is very clear. So here x equal to a, that is fixed. If x is a, which is a constant, dx will be 0. And this face is on x-axis, that means it is in yz plane. So in that case, ds will be dy dz. ds is dy dz. And we need to find n bar also, the outward drawn unit normal vector n bar. So for yz plane, outward is the perpendicular one is x-axis, so n bar will be I bar. So over the face ABQS, at that face the value of x is fixed, therefore dx is 0, and we have to evaluate along with respect to y and z only. So therefore the surface integral over the face ABQS f bar dot n bar ds is the double integral f bar dot n bar. I can consider it as only dy dz. So with respect to y and z, it is enough to calculate or evaluate the integral with respect to y and z. So before going to that, first we need to calculate f bar dot n bar. F bar dot n bar. What is f bar dot n bar? N bar is I bar. F bar is the given vector. So only 4xz comes. 4xz. Since I bar or I bar is 1, remaining are zeros. And here, since the value of x is a, x equal to a, f bar dot n bar is 4az. And we need to integrate with respect to y and z, and we need the values or limits of y and z. Limits. So y changes from 0 to a and z changes from 0 to a. That is given already. So therefore, over the face ABQS, f bar dot n bar ds is equal to y from 0 to a, z from 0 to a, f bar dot n bar dy dz first, then dy, dz dy, and f bar dot n bar is 4az, which is y equal to 0 to a, 4, so that's equal to y from 0 to a, z from 0 to a, 4az dz first, then dy. 4a is constant, y from 0 to a. Now with respect to z square by 2 from 0 to a dy. So which gives by 2 y from 0 to a dy. Here a square also comes out. So overall 2 times. So 2a cube, again 0 to a. So 2a power 4. That is the first value. A square by 2 into 4a. So which is 2a cube. And again one more a comes for integration with respect to y. So 2a power 4. Similarly, we need to evaluate over 6 faces. So coming to this second one, over the face, exactly opposite face. So the second one is OCPR. OCPR. At this surface, O is their origin. At origin x0, y0, z0. So the value of x is 0 here. over OCPR. Here the value of x is 0, that implies dx is 0 and ds is dy dz, y changes from 0 to a, z from 0 to a. And what is f bar dot, what is n bar here? N bar is a outward drawn unit normal vector. To this face OCPR, the outward drawn is negative x-axis. Along negative, this is minus x-axis. So, negative x-axis minus I bar is the unit vector along this. So, in this case, n bar will be minus I bar. Then f bar dot n bar becomes 4 f bar dot n bar minus 4xz minus 4xz, but x equal to 0. Therefore, f bar dot n bar becomes 0. Therefore, in this case, over the face OCPR, f bar dot n bar becomes 0, since f bar dot n bar is 0. Similarly, we need to evaluate the surface integral over remaining faces also. So, coming to the third one, over PQSR. So, this face is on z axis. So, the value of z is a. So, here z equal to a and ds becomes dx dy. So, n bar becomes xy. So, z axis k bar and x changes from 0 to a, y from 0 to a. And therefore, f bar dot n bar, we need to calculate f bar dot n bar. This is f bar dot n bar is our k bar, so yz remains, y into z. So, here f bar dot n bar is f bar dot k bar, so which is yz. Since z equal to a, f bar dot n bar is ay. So, therefore, surface integral over the face PQSR f bar dot n bar ds is what remains here? A into y. So, x from 0 to a, y from 0 to a, first with respect to y, then x, or else first you can integrate with respect to x and later y also. A constant, x from 0 to a, y square by 2 from 0 to a. So, that a square comes out, a cube by 2. Integral dx is again x, 0 to a. So, finally, a power 4 by 2. A power 4 by 2. And coming to the fourth one, opposite to this face, over the face, opposite to PQRS face is OABC. OABC, and since O is present, origin is there, Z is 0. And what is n bar? Outward drawn. Opposite side, there will be negative z axis, so minus k bar is the n bar here. So, OABC, OABC. Here, since origin is there, z is 0, ds is the same dx dy, x from 0 to a, y from 0 to a, and n bar is minus k bar, and f bar dot n bar is, just now we have calculated f bar dot n bar yz, so with negative axis, so minus yz. Since z is 0, f bar dot n bar is 0. Therefore, over the face OABC, f bar dot n bar is 0 itself. F bar dot n bar ds is 0. Similarly, the fifth face, PQBC, the top one, PQBC, that face is on y-axis. Over PQBC. So, this is on y-axis. So, the value of y is fixed, y equal to a, and ds is dx dz in xz plane. So x from 0 to a, y from 0 to a, and n bar is the outward drawn unit normal vector for that plane is j bar. So therefore f bar dot n bar is f bar dot j bar, and this is f bar dot j bar minus y square comes, minus y square. So that implies surface integral over PQBC f bar dot n bar ds is x from 0 to a, z from 0 to a, minus y square dz dx. But here the value of y is a. So this becomes minus x from 0 to a, z from 0 to a square dz dx. So this is equal to minus a square integral first with respect to z. So integral dz is z from 0 to a, which is minus a square into integral from x from 0 to a dx, and minus a cube, and again integrating with respect to x we get one more a, so minus a power 4. And similarly the fifth one, over the face opposite to this face, opposite to PQBC, ORSA, over the face ORSA. So here this is, since we have origin here, y value is 0, here y is 0, and ds is the same, dx dz, and n bar will be minus j bar. Therefore f bar dot n bar is minus of minus y square, which is plus y square. Since y is 0, f bar dot n bar will be 0, and therefore the over the face ORSA f bar dot n bar ds becomes 0. Hence the surface integral over the surface S f bar dot n bar ds is the sum of all these 6 surface integrals. So first one, how much we got? 2a power 4, then second 0, 2a power 4 plus 0. Now third one, a power 4 by 2, fourth again 0, and fifth minus a power 4, sixth again 0. So which is 2a power 4 plus a power 4 by 2 minus a power 4. So 2a power 4 minus a power 4, which is a power 4 plus a power 4 by 2. So 2 times of a power 4 plus a power 4, 3a power 4 by 2. This is the surface integral of the given f bar over the cube. So in today's session we have introduced the surface integral, which is calculated using f bar dot n bar ds. The surface integral can be calculated by taking the projections of the surface either on xy plane or yz plane or xz plane. And so also we have solved some problems. So evaluated surface integral of the given f bar in the given region. In the next session I would like to introduce the volume integral. Thank you.